We saw how Houstonians rushed to help each other after Hurricane Harvey slammed into their neighborhoods, floodwaters invading their homes.
So when I opened the door, more water rushed in, and all of my stuff flew out.
So many in deep trouble, and rescuers were overwhelmed.
Those of you who have boats and high water vehicles, we need your help.
The help came by boat, by truck, by helicopter. They pulled together in a crisis. They confronted a flood catastrophe. We'll confront our own catastrophe in western Washington, where the earthquake risks are clear.
The entire state is being compressed.
Tonight, we're bringing you more information on what those earthquake risks are and why you need to take preparations for a major earthquake seriously.
We've got a full team covering all the angles this morning.
On July 24th, we spent a day's worth of newscasts on King 5 and put a lot of material online at king5.com to not only help you get ready, but explain why you need to be prepared to be on your own for at least 2 weeks, even here in the city. Over the next hour, we'll bring you some new information and revisit some of the key points from that day.
And we start with this. The ground under our feet is moving. We'll tell you why and why that's such a concern. Take a close look at this map of the Washington coast. Look at those long yellow arrow-tipped lines. The land is moving, and that movement is constant. It is consistent, and it hasn't stopped since the last major earthquake 317 years ago. Each of those lines ties to a red dot that is a global positioning system antenna. One of those dots is at Neah Bay. 21 years ago, I took you out to see the first coastal GPS antenna installed, and it's not where we left it.
In 21 years, it's moved roughly 8 inches to the north. Okay, and during that same time, it's also moved roughly 10 inches to the east, and it's also actually gone up by about 5 inches. So when it started here, now it's over here.
And amongst the wind and the windmills and the sagebrush, that GPS data all comes in here to the campus of Central Washington University.
Out there, then the data turns around and comes right back down to this antenna right here in this building. So what it means is we can get data from anywhere on the coast of Washington back to CWU in 1-point-something seconds.
Tim Milburn is the director of the Pacific Northwest Geodetic Array. And that network of antennas is measuring a lot more than just the coast. And if you look, you can spot some of them. Part of that geodetic array gathering data seemingly everywhere. That dome on Bellevue City Hall, that's one. So is this saucer-shaped antenna on the Alaska Way Viaduct. Then there's this one in West Seattle. There are 500 of them, a network known as PANGA. But even here on the campus of Central Washington University, which is not only east of the Cascade Mountains, but is a long way from the coast, there is enough squeezing on this state that even here, it's moving just a little bit.
You say, okay, Idaho, this area is maybe not moving, and this part is moving a couple inches a year, then the entire state is being compressed.
We are being loaded up like a spring, because offshore there is a giant fault called the Cascadia Subduction Zone.
And eventually the stresses will overcome the strength of that fault, and all this will slide. And the coast will jump 15, 20 feet to the southwest along its entire length.
And that's why this earthquake is expected to be so big, magnitude 9 big. A quake lasting 5 or more minutes, a quake that will unleash a huge tsunami. A quake that will look much like what we saw in northeastern Japan in 2011. Some of the evidence from the last big one still stands. These trees died when on January 26th of 1700, the quake caused lowland on the coast to drop, allowing seawater to come in and kill the trees. Our world is made of shifting plates of crust. Those which make up the ocean floor are stuck, locked to the North American plate that makes up Washington. When the pressure becomes too great, those plates slip, forcing the ocean plate to be shoved below or subducted under the coast. Not just the shaking, but the fault distorts the ocean floor as it slips, triggering the tsunami. Not only that, but it's the length of the fault that will cause the shaking to last so long. A fault running from Cape Mendocino, California, to north of Vancouver Island, Canada. Quakes that happen on an average of every 250 years, meaning the next one could come any time or decades from now.
We're looking at the Cascadia subduction zone. The ground shaking, you can see it goes all the way across the state. There will be low shaking in Spokane, and then a tsunami that follows. Seattle fault zone, located in the Seattle basin, multiple faults, intense shaking around the fault radiating outwards.
South Whidbey.
This is the southern Whidbey Island fault in between Everett and Seattle. Intense shaking around the fault radiating outwards.
These are the three biggest threats we face.
I lived it, and it really changed my life and my perception of the earth and how it's not stable.
A veteran of the 1989 Loma Prieta earthquake in California, Karina Forson is now the chief hazards geologist for the Washington Geological Survey, part of the Department of Natural Resources.
So what we're looking at here are earthquakes in the Puget Sound region since 1970.
There are thousands of dots from less than a magnitude 1 to a 6.8. That dot near Olympia is the epicenter of the February 2001 Nisqually quake. No one died as a direct result of the shaking, but the region saw billions in damage. For the most part, roads and buildings were back up and running quickly. But a 7.0 on the Seattle fault that doesn't seem to be much stronger by the numbers, but runs just south of downtown Seattle, promises to be far more devastating.
But the thing about it is where the Nisqually quake was 30 miles underground, this is right here.
Yes.
Here's the difference. This aerial LiDAR image recorded from an airplane strips away trees and vegetation to expose the earth below. And that line is the Seattle fault crossing Bainbridge Island, right on the surface, where Nisqually happened 30 miles underground.
This is Restoration Point. This area was uplifted 21 feet in the 900 AD earthquake.
That was over 1,000 years ago. And unlike the Cascadia subduction zone, which happens with regularity, give or take a few hundred years, geologists don't have any sense for the frequency of quakes in the Seattle fault, which is really a complex of faults on this map that likely tie together underground.
Additionally, you look at this and you go, I-90 pretty much runs right along the Seattle fault, and strands of it cross I-5 multiple times. So if you have bridges, if you have overpasses, all of our major lifelines can be disrupted from this earthquake as well.
The rocks basically go whoop.
USGS geologist Brian Sherrod even found exposed evidence of the fault under I-5, and he has dug trenches looking for evidence of just where this fault and others go. And there's more.
In this case, this is a thrust fault, and so it's undergoing compression, and when you have an earthquake, the fault slips and uplifts, and so you can, this is kind of what we're looking at in these fault trenches. You can
that movement expected to force a localized tsunami. The wave threat no longer restricted to the coast. Seismologists expect low-lying land along the Seattle waterfront would be vulnerable, along with Harbor Island, much of the Soto district, and Inner Bay. It's also expected to travel north.
This is a tsunami hazard map of Everett, and so this is a result of the Seattle fault earthquake.
South Whidbey could be even bigger, a 7.5. Unlike the Seattle fault, there's a better sense for how many times it's gone off. Forson says 4 quakes over the last 16,000 years, but says we still need to know even more about them.
There's so much more work to be done, you know, within the basin and within all of Washington for understanding these faults and really analyzing the LiDAR and getting boots on the ground and doing detailed mapping.